let's see. Let me start right here by talking about the expected value, or the definition of, really first definition of variance, standard deviation, mean square value, and the mean value. And all the time, and we can do this either way for either the probability mass function or probability density function. I prefer probability density function simply because most of the stuff I've dealt with in radar and other things has something that's a continuous probability density, where if you want the probability of something happening, you're really integrating between the limits. So when we talk about this, whenever we talk about an expected value, they put the E in front, of any function, f, I better not use f, but g of x, we're really talking about if it is something that's a continuous variable, it's going to be an integral. Technically, that integral would go from minus infinity to infinity, but usually because the density function is limited to a range of values, it would integrate from the lower to the upper values of the function g of x times the probability density function f of x. So f of x is the probability density function. Now, and that's dx. And that's it in a nutshell. So now we take a look at some expected value definitions, and then you have to be kind of aware of this. Whenever we talk about the expected value of x, I'm assuming x is the random variable here, or we have, and sometimes they'll have an f sub x of x. They're only saying that that probability density function, the x indicates it's the density function for the random variable x. Do you follow me on this, class? And if you have that, well, it is just the integral from minus infinity to infinity of x times f of x dx. You don't need to put that sub x in. That's all it is. I could give you a ton of examples, but that's it in a nutshell. If it's a probability mass function, then this expected value of x, and that's the random variable x, but it doesn't matter if you put that up there or not. Now that's going to be a summation, and it's really going to be over the values of x. So you might say from k equals whatever the lower limit is, I'll take it as 0 to n minus 1, where there's n different values. And then it would be x of k times the probability density function x of k. Y'all follow me? So that's just something, and sometimes they do this. I don't like this, but they'll put a delta of, and then they'll have of, let me see, where he does that. Argument has to be 0, so he'll have a delta, I think here. I think it's n minus k. Now the only reason for that is when n, you can sum over n, but when the argument of a delta function is 0, it goes to 1 if it's discrete, and it goes to infinity if it's a continuous time variable. Do you remember this from signals and systems? How many do? That's the only thing. Frankly, I don't even worry about this delta function. He shows it. It doesn't really, you might mathematically make it a little more rigorous, but I just do it this way because we're assuming the probability density function. We know that that thing is only going to occur at singular value or discrete values of, I should say integer values of k, where x of k are the values of the function. Y'all with me, class? And that's it. So that's the expected value both ways. I'm going to just do it in continuous time here in this as a probability mass function of simply p of xk. The next is the expected value of x squared. And in the book I didn't see it stated explicitly, but this is called the mean square value of the function x. And that is simply the integral of x squared times f of x dx over the limits. Then you're going to get the expected value of, these are the biggies, and something else I forgot to say. Oftentimes the symbol he uses is mu. Now on your calculators, if you look at the statistical packages that are available, you're going to see mu. Do y'all have your calculators with you? And now I'm not familiar with PI and all the other type of Casio. I'm an old HP guy. But if you look in there in the statistical packages, you're going to see something where they're going to have a overall probability. We'll get to this is the cumulative probability density, but they'll have probability. And it will have like x and then mu. Now, and then actually you'll have this. You'll have x, mu, and I think it's sigma. Sigma is the standard deviation. Can you take a look at your calculator if you have them with you? Look at the statistical packages, whatever they call them. I don't know. If you have TIs, they'll probably have a different name than Casios or. Do you see it?
I'm trying to find it.
I don't want to spend too much class time with this. The reason I'm pointing this out now is you're going to be using this all the time. And it's better to use your calculators and look up tables. He has all these tabulated things. Bashir has you look up tables a lot. I don't personally think you need to if you know how to use that. Go ahead. You see it?
Oh, I was just.
I'll get to, look, take a look, see if you can find it. It's a statistical package. Now, this is a cumulative probability density function. So, let me add one more piece to this puzzle. You might see something in your calculators that look like this. F of x, and that's an integral from minus infinity to x of f of x dx. What it's saying is the probability of x having a value equal to or less than the argument of f of x. This is called the cumulative distribution function, or CMF, which is logical. And then there's also the f of x of k, and that is simply the summation from the lower limit, and I'm going to say k equals 0 to, or I got to use a different variable. That's right. And this would be like I equals 0 to k of, and this is going to be P of K, or P of I, pardon. And the only thing you're doing here is taking the probability that an event, that the value here, x of k, where k is going to be the subscript for the value of x, is less than what it is here. Now, something about these cumulative distribution functions, if you let x go to infinity here, it goes to 1. Y'all remember this? The probability of something happening has got to be 1. That's the correct density function. It can never be non-negative. I'm saying that again. It can never be non-negative. Occasionally, I'll see that. And the other thing is, y'all follow me on that? You can't have a probability as -1. It's makes no sense. It's like saying I got a mass that's imaginary. It doesn't work. Or a temperature that's imaginary. Not in an observable domain anyway. Well, what we're really talking about here is some of the properties of the cumulative distribution function. So they have to, in a limit, when you go over the entire range, go to 1. That makes sense. In his book, how many read this stuff in the book? Anybody? If you look at that, he says it's got to be monotonically increasing. It means you can't have a probability from 0 to 3 that's greater than the probability from 0 to 4. You all follow? Because that range is encompassed in the actuals. mean the 0 to 3 is encompassed in 0 to 4. It has to be monotonically increasing. And that also means that f of the density function, because it can't be negative, the density function itself has to be positive. You with me? Has to be positive. If I give you like a cumulative density function, and I ask for the probability density function, I think you can see this relationship. F of x is the probability density. So f of x is just equal to the derivative of f of, this is the cumulative distribution function divided by x. You know, follow me? It's just the derivative. How many understand that? I hope you did the problems, because these things are implicit. I mean, they're obvious if you look at this. Okay, I'm saying that for a reason, because back to here, this is the mean squared value. Now we're going to look at the estimate, and this is called the variance. Right here, and the variance is equal to the value x minus, and he likes to use the mean value squared. Do you remember seeing this in the book? He uses that mu for the mean in the book a lot. Yo, do you remember this class? Now, this is an important one I'm about to show you. So that's equal to, if you look at this, let me do it up here. Did anybody find the statistical packages on your calculators? Oh, please make a note to look that up. It'll save you time like you wouldn't believe when we get into the Gaussian distribution stuff. Okay, now over here, I want you to take a look at, let's go ahead and square this out. So this is the expected value of x squared, and then it's minus 2 mu, and this is going to be x, and then it's going to be plus u squared. You agree with that? Just multiplying it out? Let me come up here and do something. I'm going to go from there over to here. I want to make sure you see this. I'm going to do one other thing. This is something that is interchanged all the time. The expected value of x is the same thing as mu, and it's often given this symbol. Anytime you see a bar over something, like x bar, y bar, it means the average value. Follow me on this? I want to just make sure. You all with me on this, class? Now, if you look at this, and I'm going to use this and bring it over here, I can say what I really have is the expected value of x squared minus 2x times x bar. He does it this way in the book. And then it's going to be plus quantity x bar squared. Just take a look at that and convince yourself what I've written is correct. Y'all see it? Okay. Now, because this is a linear operation, that means it's the expected value of x squared right? And then it's minus, really I can take that 2 out in front, 2, and because x bar is a constant, I can take that out in front, times the expected value of x, and it's going to be plus. Now, the expected, I didn't say this, but the expected value of 2 is what? It's as obvious as you say. 2. Right? There's no possible, any other value in the universe can't be part of that. The expected value of A is A. Expected value of P is P. Follow me? There's only, if it's a constant, any constant, doesn't matter if it's imaginary, if it's real, the expected value of any constant is the constant. It's the only possible value that there is. So if you look at this, this is a constant, right? X bar is a singular value. It's a constant. So that is just plus x bar squared. Do you agree with this, class? I really want to make the point. Now, this is real important Because this back here was, the symbol for that is variance, sigma squared. Symbol for variance is sigma squared. Do you remember that on Friday? It's just that it's universal. If you look at this, then what I really have is I come here, here's what you'll see. I got sigma squared or the variance, and he'll use this. He has VAR of whatever it is, X. And oftentimes if we're talking about a variable with a density function of X, he'll put a sub X there. It's usually implied. You all with me? So sigma of X squared, or the variance, bless you, is equal to, now look, it's equal to, now that is X squared, and here's what they do, they'll put X squared bar. You gotta be careful reading this stuff. You see how the averaging, where the bar means average, is of X squared. You see that? That is this. You understand? Every time you have a bar over any function, like if I have this, G of X bar, what that is the expected value of G of X. That's all it means. The bar means expected value. We're used to assuming that's a vector term, right? Bar is vector. Here it means expected value in statistics, probability, and random signals and systems. So it's equal to that minus, now just ask yourself this, that X bar is a constant. Do you agree? What is this? X bar. So this is 2x bar squared. Can you see this, class? So this is minus 2, and then it's quantity X bar squared. Are you all with me on this? If I'm going to, I'm trying to fly through this, but I don't mean to. If you've done the homework, this is what it's about, right? Y'all got that? You know, the serial note takers, I admire you. I try to time my lectures by your handwriting. When you stop, I mean, if you're writing, I stop, wait. I used to take notes, but I had like a short, you know what shorthand is? It's like different words. My shorthand was different than anybody else's, but I knew what I was talking about, and I could condense 30 words into maybe 4 or 5. I have a friend that's really good at that. Anyway, plus X bar squared. Do you remember this in the book? Him doing this or not? If you don't, this should be very useful because there's something obvious that happens. Take a good look at this. What is 2x bar squared plus x bar squared equal to? 1x bar squared, right? So you get sigma x squared is equal to x squared bar. This is one of the things x squared bar, that's the average of x squared, and it's going to be that plus x bar squared. Now, this is important, so this relates to statement. Yes, sir?
Would it be minus?
Minus, my bad. Trying to go too fast. I'll slow myself down on purpose. You're absolutely right. Are you with me, class, on this one? Yell at me if I make a mistake. Now that's the variance of x, but the standard deviation, write this down too. Is the symbol is sigma x, and it's the square root of sigma x squared, or the variance squared. So that is called the standard deviation. Have you heard the term standard deviation before? Usually, when you do grading, there's a statistical form it takes if you get a lot of students. It's called the Gaussian distribution. Have you heard the term Gaussian? The standard deviation is a measure for how many students. First, the mean value, and we'll get to this. There's something called a mean, there's the mode, and there's the median. I'm going to get to this in a second. These are different terms that mean different things. But for a large class, usually distribution is something we call Gaussian that we're going to get to. And if you know the If it's very large, the mean value, or if it's not that large, the median value, just trust me, think of it in the middle. Then one standard deviation above and below is about where about 90% of the students should fall. And we'll show you this. Do you remember this at all? And then if you think about this, 5 standard deviations away from that middle, and 99.9% of everybody is within that range. I'll get to this. I gotta be careful when I say this because there might be a few more 9s after that, but in other words, a whole bunch of people. Very few people are outside that range, if it is the Gaussian distribution. So you get down to this, and now I've done what I need to do in terms of definition, the definitions of this. Now let's do some problems. Wish I had my book. Do you have your book? All right, I'm going to ask you this. Do you remember, I believe it's exercise, it's in the problem section, it's 3.2. You got 2 dice, and the value of the random variables, absolute difference between the 2 dice that are rolled. The difference in what basically, if you had a 1 first roll and a 3 second roll, the absolute difference, regardless of if the first or the 1 was on the first or second, or the 3 was on the first or second, the difference between those is 2. Let me do this one with you. And I want to make sure that I know who I'm talking to. So I'm going to try that problem. 1, 2, 3. All right, it's a good problem. You know, the solutions, but these have video solutions. And I checked with ChatGPT. ChatGPT got the right answers for these. Sometimes I check and it gets the wrong answer. It really is good at getting the wrong answers for certain problems, but I got the right answers for these. So maybe it's improving. My wife said that, you know, the thing's a learning algorithm, so as time goes by, it's going to get better and better. Probably true. I'm trying to learn. I'm going through learning neural nets, convolution neural nets. I'm starting it. I don't know if I've said this in the class, but I'll say you this. If I was sitting where you are, career-wise and everything else, I would do everything in my power to take courses related to neural networks, AI, because that stuff is used, it's everywhere. The term that they use is ubiquitous. It's being used by everything, and I mean everybody, everywhere. And the power of that thing is phenomenal because it's basically emulating how you learn. And this thing learns, not just never forgets, but it's an accelerated rate. So this stuff, I don't know what you're going to see in years to come. I mean, your car may have a conversation with you about where you want to go. Forgot about your wife's birthdays. You know, it's that kind of stuff. Things that are useful, making sure you're not in too much trouble at the end of the day. So this problem says this. You got 2 die. This is 3.2. And 2 dice, or 2 die. We roll them. And we're letting the random variable x be equal to the absolute difference between die 1 and die 2. Y'all with me? Now you can watch the video solution. I don't suggest you do that right away. I've learned one thing about, at least myself in learning, when I was in college where you are now, and I had solutions manuals, or sometimes I didn't, but I had answers. Actually, most of the time I didn't, but I'd have answers maybe to odd problems, physics, math, engineering, all my double E courses. What I'd do is go through the problems, never look at the solutions at first, and see if I got the right answer. If I did, I felt confidence, there's a confirmation, you know how your thinking's right. Whenever I got the wrong answer, I go back and look through it and see. And if I can't find a mistake, if I had solutions, I'd look at that. If not, I'd make sure I mark that down, and I would go and talk to the professor or other students and find out what I was missing. It will reinforce that, and you don't forget that. Trust me on this one. It's very important to never go at problem solving something Oh, I just gotta go through it. Oh, I don't see it, forget about it. You won't learn the material. You'll forget it, you'll just stumble all over yourself in a big exam. And in the real world, you'll stumble. So let's go through the possibilities. Here's die 1. I can get 1, 2, 3, 4, 5, 6. Do you agree with that? Call it die 1. And then die 2. Now I can get 1, 2, 3, 4, 5, 6. Now what I did yesterday evening when I was doing this, I said, well, let's see all the possibilities. Well, if you think about that, you can have for the first roll in the difference in this thing, here to here. Take the difference. So x could be equal to, if you roll a 1 in the first, 1 in the second, you get 0, right? I'm going to go down this way. This is one possibility. 1 in the first, 2 in the second, you get a 1. 1 in the first, 3 in the second, you get a 2. 1 in the first 4, 3. 1 in the first 5, 4. 1 in the first 6, 5, right? I'm just showing you, this is the way I did it. Now go to the next possibility. Roll a 2. All right, 2 minus 1, difference is 1 right here. So up here, this would be the first, and now I have 1, then 0, then 1, then 2, then 3, then 4. Next one, you can see the pattern. It's going to be 2, 1, 2, 1, 0, 1, 2, 3. Follow me on this, class? And we can extend it onwards. Do you agree? Did anybody do it this way? You did it that way? Good. How else did you do it? Huh?
I did it like that. I just organized it differently.
Well, you can have different organizations, but in essence, what it showed the pattern.
Yeah.
And then once I grabbed the pattern, I could see what these. Anyway, let me just finish this. Then you can get 3, 2, 1, 0, 1, 2, 4, 2, 4, 3, 2, 1, 0, 1. Finally, you get 5, 4, 3, 2, 1, and 0. And you take a look at that, right? Now we've got to get the probability mass function. Do you all know what I'm doing here? Those are every possibility that can happen when you roll those 2 dice. First, you agree with that. You don't have to write them down like this, but you have to see the pattern to know what they would be. Y'all with me? This is the kind of stuff that you get, and if you do the problems, you'll see it right away, and you get it on a quiz or exam. But if you don't, you'll stumble through this thing, and usually I don't know what to do. So I'm trying to help you. I get down to this. Now the first thing I want is the actual probability of a 0. And this is the probability mass function that we need. For a 0, now just take a look at that. That's the easy one, right? How many values are there? 6, right? How many total values are there in that matrix? 36, right? So it's 1/6. Probability of 1. All right. Here's the pattern I see. Here's 1's coming down to here, and then here, right? How many do we have?
10.
Huh?
10.
For 1's, I'm sorry, I gotta go down this way. Y'all see that? And if you look at that, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're right, 10. So here I got 10 over 36, right? How about P of 2, you wanna give that to me?
8.
8 over 36, P of 3?
6.
6 over 36, P of 4?
4.
Is that right? Yeah, I guess it is. 4 over 36 and P of 5. 2 over 36. Is that correct, class? Is that in the video, the solution? Videos? I didn't see the video solution. Pardon me?
Yes.
All right, now we've got that, right? I'm gonna Yeah, I'll leave it on. So I think the next thing he asked for is, and I might be wrong about this, but I think it's, oh, I didn't say this, but I realized I have a grader. My grader contacted me, I didn't know that. And for both classes, so the grader is going to get your quizzes today after this class and have them graded by Wednesday, okay? But the solutions are up there, right? Did y'all see them? They should be on OneNote. I want to make sure everybody can access that. You can get it, right? All right. Did anybody have trouble in this class? Somebody did in one of the classes. Okay. Anyway, now let's see. What does he ask for first? The expected value?
He asked for P of X is less than or equal to 2.
Oh.
Or P.
All right. So P for X less than or equal to 2. Now, really, what we're talking about is what? This value, this value, and this value for the probability mass function, correct? You agree with that, everybody? Because this is 0, that's less than 2. 1 is less than 2, and 2 is less than or equal to 2. So that's going to be equal to I'm going to use K here from 0, and this is going to be, my values are going to be 0, 1, 2. Actually, I can use X here. So first it's got to be, now the form of this is going to be V value X times the probability of that. So the first, yeah, I'll just put that one. It's going to be X times the probability mass function of X. So for this one, I start with 0 times 1/6, right? That's 0. Do you agree with that? That's the first one. Plus, then it's going to be 1 times, and that's going to be 10 over 36. And finally, plus 2 times 8 over 36. And if you look at this, let's see. We got 10 plus 6, we got 10 plus 16, or 26 over 36. And what's that? Isn't that right? That's 16 plus 10. Do you agree with that? Oh, and this is a 2 times the probability of 2 is 8 over 36. Do you agree with that? You follow me on this? Do you have a different answer?
Mm-hmm.
You have a different answer?
Mm-hmm.
What is it?
I got 24 over 36.
Okay, maybe I did something wrong here. Probability that's less than or equal to
2. I don't think for this problem I've multiplied like 0, 1, 2.
well, it's got to be 0 there, right?
No, that's not what you did.
Oh, I'm sorry. You know what I did? I'm doing the mean value. That's on me.
Except it wouldn't just
I'm
be,
sorry,
it
it has
just
to be
you already
0.
have the probabilities.
I've got the probability mass function, and it's just summing that. This is a mistake on my part. It would be 1 over 1/6 plus 10/6 plus, and this is going to be 2 times 8 or 16/6.
It's
16
10 over 36.
36, pardon. 36, my bad. And this is going to be 2 times 8 is going to be 16 over 36. My bad on that one. So this is going to be 6 and 10, or 16.
I think it's 8 over 36.
What? Say again?
8 over 36.
Oh.
Not 16. Because remember, we're not. Or I don't
Oh,
remember.
oh yes, you're absolutely right. I'm doing it again. You are absolutely right. So that's going to be equal to, that's basically 6, okay, that is 24 over 36 euros. My bad on that one. Now, I think he asked for the mean value, right?
Yeah, next he asks for that and the variance.
Okay, now, I'm going to just say this, because, sorry for the mistake. For the mean value, you're going to take these density functions and multiply them by the values and add them together. So you're going to take 0 times 1/6. or 0, plus 1 times 1036, or 1036, right? I can write this down. The mean value is going to be at 0, that's 1036, because it's 1, plus 2 times that is going to be 1636. 3 times that is 1836. 4 times that is 1636. And finally, 5 times that is 1036. And the only thing you need to do is add those together. Do you agree with that, class? And that would be the mean value. With me? That is correct. That I'm sure. Now you can add. You got a cap, but what can you do with this? Well, I got 10, 20, right? Then I got 20 plus 32, right? So that's 42 plus 18. I'm sorry? 52. Yeah, and is it 5336?
Oh, the answer, I got is 35, 18.
That's what I got.
Yeah, but that is divided.
Oh, yeah, sorry.
Yeah, I mean, it's the same thing.
Yeah, sorry.
What, they asked for the variance, right?
Yeah, after that, yes.
Now, you see, this is just a simple mathematical statement. Now we take these, instead of multiplying it by the singular value of the variable, like 0, 1, and down the line, 2, 3. Now it's a square. 0 squared is still 0. That's going to be 1. This right here is going to be 4 times that. This is going to be, it's basically 9 times that. This is 16 times that. And this is going to be 25 times that probability density. You got to add them up. Do you agree with that? And he asked for the standard, or the variance too. But once you have, now can you just give me the, this is 18, did you say?
35 over 18.
35 over 18? And so x squared bar right here, if you did it, can you give me it? I mean, basically, you know how to do that, right? The mechanics of that, you're just squaring. I don't
think I actually wrote it.
Don't worry about it. Here's the deal. If you have these two, to get the actual value of sigma of x squared, or basically it's the expected value of x minus x bar squared, the only thing you have to do, remember the formula I showed you? That's going to be what? X squared bar, right? And it's going to be minus x bar squared. You remember that? Just take a moment and write it down if you need to. But the only thing, see, what I think he's trying to teach you is you do not need to recalculate this. The prior two calculations will give you this answer because we have this, that's x bar squared, whatever it is. And we have x bar, which is over there, so we have to square it. Y'all follow me? And that's all you need to do. Do you agree with that, everyone? Please make sure you go through the mechanics of this and know how to do it. Now, on your calculators, you should have a means where if you enter, well, you gotta be careful with this. No, actually,
I think I did actually write it down. X squared bar.
what is it?
It's 35 over 6.
It's 35 over 6?
Yes.
All right, so if that's the case, then the variance of x is going to be, it's going to be this, 35 over 6 minus, and it's going to be this squared over 18, but the quantity will be squared. Do you agree with that? If I'm using that formula, right? And what's this value?
I think it's 665 over 324.
Say it again?
I think it's 665 over 324.
Well, okay, 665.
Yeah, 2.05.
2.105?
Well, just
Oh.
05.
2.05.
Yes.
Sorry, I just do fractions on it.
Okay, y'all with me? It doesn't matter. Either one, I don't know what the video solution is, but that's the way to do it. I didn't even spend this much time on that one, but it's important you see it. On the, right here, what I've done is I got the probability mass function, it's got all sorts of sketches, but I think in essence you see it, and his solutions are pretty good. So then it's exercise 3 is that it's C over 2 of K for K equals, so make sure you follow me on this one. Now these are the ones that confuse students if you haven't done it before, or at least, in my opinion, they can confuse you. All right, as I recall, for this one, he has some P, and I'm just gonna call it P of K. And it's equal to C, I think it's 1/2 to the K, and it's for K equal 1, 2, 3, on out, correct? With me? Now, I'm gonna say this, these are the things that will irritate you. So that's the reason from the first lecture where I did those summations, just listen to me. So I did the thing where if you have a summation of A, and I have, I think I called it A to the K. First I had K equals 0 to infinity. And what I ended up doing was creating, I did this thing because it's a geometric series. Anyway, it ended up being 1 minus 1 minus A, if this goes to infinity. Do you remember that? How many do? Okay. This is necessary for this one. You can go further and say that if you have a summation, and here I'm going to say where K is equal to A, or maybe not A. Let me say, I think he uses Q1, or somewhere it says Q1 to Q2 of A, and here this is going to be K, it's a summation of K, A to the K. It's going to be equal to A to the Q1 minus A, and here it's going to be Q2 plus 1 over 1 minus A. We can prove that if you want. Remember how I proved this thing? I took this series and I wrote it out term by term. 1 plus A squared plus. And then what I did is subtract this series multiplied by A from that. So I have 1 minus A times this stuff, and I divided, after I crossed out all the terms, I divided what resulted by 1 minus A to get it. Do you vaguely recall this? Okay. Now, a lot of people forget that, but it's so useful, and this is where it's useful. So, first for this one, if I just call this, I don't care, f of A, and then if I take a derivative of f of A with respect to A, what I end up getting is the K comes out in front, and I get, now you probably remember this, the summation of K times A to the K minus 1, here K goes from 0 to infinity. I'm just taking the derivative of this, and over here, that's going to be equal to 1 over 1 minus A squared. Do you all remember that? And then you can take the A to the minus 1 out in front. And now, you can see if I have that, I multiply both sides by A. Trying to get down to brass tacks, I get this. Remember? I'm just showing you that will give you this value. There's a lot of ways to do it. I think, now I gotta be careful about it. I think your calculators have a way of calculating these things very fast. As a matter of fact, I'm gonna go on to say this. instead of k, a to the k, you might have k to the n. N could be 1, that would be this. K could be 2, k squared times that. And there is a reason for k squared, because that will come up with the x squared bar term. And they have all sorts of stuff. Are you with me, class? First thing I'm going to do for this one, and I'm trying to get through this, I need to move so quickly. I'm trying to slow myself down. First thing he asks for is what value of c makes this legit, right? So what value of c makes this legit? It means that this would have to be true. The summation of that, and I'll bring the c out in front, 1/2 to the k equals 1 to infinity has to be equal to 1. First, do we agree with that? Why? Because that's a probability mass function, and if you sum up all the values possible for the probability mass function, it has to go to 1, or it's not legit. You with me on this, everyone? Now look at this and see. If I have this right here, first of all, I have, if I look at just the summation of let a be equal to 1/2, and I'm going to reference what I have over here, and I know that a to the k, where k goes from 0 to infinity, is 1/1 minus a, right? Agree with that? So if I take that, I can say that's the same thing as the summation from k equals, and here it would be from 1 to infinity, a to the k, plus 1. Now here's what I've done. See the first term of this, at k equals 0? Well, a to the 0 is 1, right? So what I did is I subtracted that off, and I said, or I basically said this, if I expand this, and instead of going from k equals 0, k equals 1 to infinity, I just have to add 1 to it to get this. Follow me? How many understand? I'm just finding a way to get the form I need. So what that means is, if I take this minus 1, or if I take 1/1 minus a minus 1, I have this, correct? And now look, that's a c, right? I'm going to put a c in front of here. That's 1/2 to the k. And over here, since that's 1/2, I have 1/1 minus 1/2, right? I think you can see this. Well, that's 2. 2 minus 1 is 1. So I have 1 equals, and well, frankly, when I do this thing, that means c has to be 1. Y'all follow me in this class? Maybe I didn't say it that clear. I know this series right here that series right there goes to this, and if I multiply by c, I get c equals 1. Please just take a look. How many see this right here? All right, I'm trying not to make it too complicated. So if I got c there, the next thing he asked for is, I think I know the answer. He asked for y. The expected value of whatever this is. Does he use the symbol k or what for this? Is it k?
For what?
The probability mass function, he has c over 2 to the k, right?
Yeah.
So it's c really times 1/2 to the k. Do you agree with that? All right. And the next thing he does is he wants the expected value. So the expected value of the function, or the expected value, yeah, it is a function, okay. I equals 1 to infinity, or maybe I can use k, okay, of k times 1/2 to the k. Now, if you're, do you remember this?
There was a part before this too. but
What else did he want?
He wanted the, probability of x greater than 4.
Okay, we can come back here to, how do you get the probability of x greater than 4? If the probability density, probability mass function is equal to 1/2 to the k, right? And here k equals 1, 2, 3, and 4. How do you get the probability of k being less than or equal to 4? Isn't that right? Okay, so the only thing you do is add them. If you look at this, there is no k 0, right? There is no p of k and k equals 0. So what you're really going to do is when k is equal to, this would be the probability of k being less than or equal to 4, would be equal, now you take k equal 1, it's 1/2, plus 1/4, right? Plus, and this would be 1/8, right? That would be 3, plus, and this would be 1/16. You agree with that? That would be 1 through 4, correct? And just add them up, what do you get? Let's see, 16 is the common denominator, so that's going to be 8, right? Plus 4, plus 2, plus 1, and that's 12, 14, 15 over 16. Is that right? Excellent. It's got it. You follow me? Did anybody, you did this one?
Yeah, I had some trouble with it, so
Do you follow me on this?
yeah, I'm following.
Everybody with me? What's the next part? I'm sorry.
To, like, for this part, or no?
Well, I think the next part is the expected value of k, right?
Well, I think, he asked for the probability of x greater than 4, so wouldn't you subtract that from?
X, I thought was less than.
No, x greater than 4.
Well, if
So
that,
you just subtract that.
yeah, if this is x, I'm sorry, I've got k less than.
No, but you use that, so, right?
You can use this, just take 1 minus that.
Yeah, that's what.
So if, for the probability it's greater than 4, it's 1 minus that. Do you agree with that?
Yes.
If that's 15 16ths, it's 1 minus 15 16, or really 1 16th, correct?
Yeah, and then the last part was the expected variance.
All right, now, not variance, I think it's value of. Isn't it just k?
Pretty sure he asked for e of x and var of x.
You look, what is x?
Didn't he ask for variance too?
I think so.
All right, the only thing you're going to do, this is going to be the expected value of that, right? And if you take a look at this right here, I've got one more thing to cover. If you look over here, that's this right here. If you look at, you follow me on this? Now you would subtract 1 from this. Do you follow me? Because it starts at 0, you'd subtract 1. But you notice at 0, what happens? 0 times anything is 0, right? So you can say that this is effectively from k equals 1 to that. Will give you this. We can do, you can do this. You with me, class? It's just using this and plugging it into that value. A would be 1/2, correct, class? And that would be the expected value. You get the variance, what do you need to do? You got to square k, right? Now, some of you are probably thinking, do I need to know that one too? No. That one, any higher ordered thing, I would provide that for you if I asked you, but I'll tell you, your calculators will do these things. I'm not familiar with how to do it on your calculators. But all these things are a form of geometric series, and they all can be entered into your calculator, I believe at least, to get the final answer. I'm sorry, I'm going so slow on this one. I work these things. In chapter 4, I want to do at least one of these problems. There's some tricky ones here in chapter 4. Let's do chapter 4, the first one for the values here. I want to apply this to continuous time. I'm looking at it, it's 10:54, and I was 5 minutes late, and I apologize. But I really wanted to do one of these before I move on to some newer ideas. And I don't think I'm going to be moving on to those ideas today. But this stuff's really important. Matter of fact, I'm gonna create a problem about this. Instead of just going through the mechanics, I wanna do one, and that way you'll see how this is applied. Right here. Now, please, I know you've been going a long time. Usually 50-minute mark, 50 or 60-minute mark, people start fading. Just catch your breath and listen, this is important. Here's my probability density function for my f of x. It's gonna be uniform. I'm gonna show it to you. We're gonna go from a value from 0 to 9. So you think about that, the area under that curve, or the width here, from here to here would be 9, and you can call this value x. And that means the f of x, if it's uniform, this would be my f of x, this value would be 1/9. Do you agree with that? Why is that true? Just tell me. This is, what do you know one of the things is? The integral of f of x dx from technically minus infinity to infinity, in this case from 0 to 9, has to be what? 1, right? Make sure you see that. The area under the curve has to be 1. That's one of the things. Now, if I look for, and listen now, what is the expected value of x for this one? It's real important. You should be able to see it like this. If you can't, listen up. Ask yourself that and tell me how to do the problem anyway. Well, mathematically, this is not a summation, it's an integration, right? So it's an integration over the total possible ranges of the value x from 0 to 9. Do you agree with that? All right, now what do you put in? Expected value would just be, it would be the function of x, right? It's the expected value of x times f of x. F of x is a constant, or 1/9, yeah, dx. Now, I'm asking, just please, be able to solve this almost smiling, like, huh, what a simple problem. This would be 1/9, right? The integral from 0 to 9 of x dx. These are the type of integrals you love, because they're no-brainers in a sense. So this is going to be 1/9 x squared over 2 from 0 to 9, or really I get 9 squared over 9, right? Times 1/2, or I get what? 9 divided by 2, or 4.5. You agree with this? Now look here. 4.5, there's something very important to see in that. That's dead center. Y'all follow me? If you have a uniform density function, the average value is dead center, or the mean. Can you all see that? What would the expected value of x squared be for that one? Anybody want to help me? It's an integration, correct? You're very quiet. It would be an integration from where to where? The limits, anyway. Where's the lower limit? Yeah, where's the upper limit? 9. Does everybody see this? I'm trying to get you to work with me. It'll help you retain information. It's the expected value of x squared. What goes here? X squared. And it's times the density function, which is 1/9, right? Right? I mean, it's just 1/9. It's a constant. That's the reason I chose this one. This is one of those things you dream of. All right? So it's x squared dx times 1/9. What's that going to be? 1/9, right? And then I have an integral from 0 to 9 of x squared dx. Or what do I get? 1/9, right? And then I'm going to have x cubed over 3, evaluated from 0 to 9, or 9 cubed over 3. Agreed? That's 9 squared over 3, or 81 over 3. Do we agree with that? So there's a very good example. By the way, I didn't plan to do this one, but I think it really shows you how to do these problems in a very easy way. Now ask yourself this. Please just don't jump the gun yet. Get out of here. Just let me finish this. So how do I get the expected value of quantity x minus x bar squared, commonly known as what this is going to be the variance of x. That is, if you remember, it's what? X squared bar minus x bar squared. I know you just got this information with me. First, do I have x squared bar? And 81 over 3, all right? 81 over 3 minus, what is x bar? 9 halves or 4.5, but you got to square it. I don't know what that is, but that's how you would do these things. You with me, class? I'm trying to make sure you see the mechanism. It's very straightforward. Get the actual mean value, get the mean squared value, then you get the variance. Now, I have 2 other things to say. I'm not going to do these examples. I've got a bunch of them. There's 3 things. He talks about the mean, the mode, and the median value. Do you remember that? So the mean value is the same thing we just did. That's the average value. So I'm not even going to bother with that. Now the median value is an important fact. This is important. And it's for, the median value is something that really is more important when you talk about discrete values. And I'm just going to cut to the chase on this one. I wanted to make sure I talk about median value. Is the middle value. And it's really middle. You don't need a formal definition. Here's what it means. If you have numbers, 1, 5, 6, 8, 9, something like this. And if you put them, now order is important. So if they had, these numbers could be like 5, 6, 1, 9, 8. You with me? If you order them in increasing value or increasing order, you would get this. The median value is just the middle value. That's all it means. So it doesn't matter how many numbers, you have to order them from least to greatest in numeric value. And whatever's in the middle, that's it. Now, a logical question is, that works great when there's an odd number. But if there's an even number, the median value can't be something that's not realizable. The median value could be 1 or 2. It could be one of 2 values. You with me? Usually there's a preference for the lower value, but don't quote me on that. It may be the upper value for some other things. Usually it doesn't matter. Median just gives you an idea of where the center is of that group of numbers. That's all it is, but it's be important in later things. Now the mode is something, did you remember reading this in the book? I'll talk about that next time, because I am holding it. I thank you for bearing with me that extra few minutes. This lecture makes sense. It's real important to understand.